we are back at AP Review. This is 2006, BC Free Response 6. You're given two series. The function f is defined by this power series for all real numbers x for which the series converges, and the function g is defined by this power series for all real numbers x for which the series converges. Part A, find the interval of convergence for the power series of f. Justify your answer. So most of the time when we're asked to find the interval of convergence for something, the easiest way to do that is the ratio test. So part A, we're going to find the interval of convergence for f. So we're going to do that, right? We're doing it for f. We're going to do that by finding the limit as n approaches infinity of a sub n plus 1 over a sub n, all inside an absolute value. Right, and we want to set that less than 1, and then we'll find our endpoints, right? So we want that specifically to be less than 1, but we'll get there in a sec. So that is the limit as n approaches infinity of, I'm going to take this nth term and make it n plus 1s. So I'm going to get a negative 1 to the n plus 1. The negative 1s are going to completely and totally be irrelevant anyway because it's inside an absolute value, but that's cool. We get an n plus 1, we get an x to the n plus 1, and on the bottom we get an n plus 1. And then that whole thing is going to be over the original term. We get an n plus 2, my bad, n plus 1 plus 1, which would be n plus 2. We get a negative 1 to the n, we get an n, we get an x to the n, and we get an n plus 1. Cool. Ugly, ugly monstrosity that it is. Now, when I flip everybody and clean this up, everybody's going to have a matching partner, right? Like the x is going to have another x on the other floor. So what ends up happening is I get a negative 1 to the n plus 1 on the top, and its matching buddy of a negative 1 to the n on the bottom. I'm going to get this n plus 1 on top of this n plus 2. And I'm also going to get this n plus 1 on top of this n, and we'll talk about that in a sec, right? And then I'm going to get, or if you want to think about the pairing better, it's actually slightly different, but that's fine. And then what's going to happen here is I'm going to get an x to the n plus 1 over an x to the n, and that should be everybody, right? So essentially what happened is anybody that was on the top floor here ended up on the bottom floor. Like these three ended up on the bottom, and anybody that was on the bottom floor here ended up on the top floor. Cool. All right, so now a bunch of stuff's going to cancel, right? So these guys are going to net as a negative 1, which is not relevant because it's inside the absolute value. These guys are going to net to an x, right? Because the x to the n plus 1 minus an x to the n, minus the n would be an x to the first. And then these guys, interestingly enough, these are the guys that the limit as n approaches infinity pertains to. So the limit as n approaches infinity of this guy, and if you want to write him out as an n squared plus 2n plus 1, you can, and on the bottom he's an n squared plus 2n, right? This guy's the only thing the limit pertains to, right? Like the absolute value of x, which is the only thing left over, and this guy's irrelevant because he's inside the absolute value, so you absolute value a negative and it's still fine. This thing is going to approach a 1 because you only care about the degree of the leading terms, which are the same here, and then if they are the same, you care about the leading coefficients, which are both the same, so you're going to get a 1 over 1, which is a 1. And this whole thing is less than a 1. So after all that work, essentially what we get is the interval. So what we get is, for part A, that the absolute value of x is less than 1, which gives us essentially that the distance from 0 is within 1 unit in either direction, which essentially gives us negative 1 to 1. So this is what you're looking at, right? But then we have to check the endpoints, right? So what we need to do now is we need to see if this series converges or diverges at the endpoints. So if I check x is negative 1, I go to my nth term, right? If I plug in negative 1, I'm going to get a negative 1 to the n times an n times a negative 1 to the m, which we'll deal with in a sec, over an n plus 1. So what's going to happen is I end up getting a negative 1 to the 2n times an n over an n plus 1. Well, negative 1 to the 2n is a positive number because 2n is an even number, and negative 1 to an even comes out as a positive 1. And the limit as n approaches infinity of n over n plus 1, right, of n over n plus 1 is a 1. So by the test for divergence, this thing diverges because these are basically infinite 1s forever. 1 plus 1 plus 1 plus 1. So that diverges. When I check 1, I get that this is a negative 1 to the n times an n over an n plus 1. Well, this means that this guy's still alternating, right? But n over n plus 1 doesn't go to 0. Doesn't go to 0. For an alternating series to converge, what ends up happening is that this positive part of the term, the n over n plus 1, would have to go to 0, and it doesn't, so this side also diverges. So it ends up that my answer, which is always sort of not super satisfying, you kind of want one of them to converge, but neither of them does, and the answer is that neither converge. Your interval is -1 to 1, exclusive, the endpoints are not included. Cool. Part B. Oh, by the way, that was worth a ridiculous number of points. That was 1 point for setting up the ratio, 1 point for finding the limit as n approaches infinity of the ratio, 1 point for identifying the fact that it's 1 unit apart in either direction, right? So for finding that one, considering both endpoints, and then justifying that both endpoints diverge. So the fact that you even mentioned that you had to consider the endpoints got you a point. So that was 5 points out of the 9, which is a significant number. Part B. The graph of y equals f of x minus g of x passes through the point 0, -1. Find y prime of 0 and y double prime of 0. Determine whether y has a relative min, relative max, or neither at x equals 0. Give a reason. Okay, so here's the thing. Before we even do this, so, well, we know that y equals f of x minus g of x. Great. Okay, cool. The first thing I want to point out is that when they ask you max, min, or neither, and they ask you to find both the first and second derivative at a point, they're doing the second derivative test. So before you do anything else, right, when they say max, min, or neither, right, and they ask about y prime and y double prime at some point, it's the second derivative test. Every time. Okay, and let's just review what the second derivative test looks like. If something is concave down, and flat, then you have a max. So what that would look like is, let's just call this some point A. That would look like y prime of A is 0. That's why it's level, right? And y double prime of A is less than 0. Oh, look, it's a max. If something's concave up and flat, it's a min. So that would look like y prime of A is 0. That's the part that gives you a level horizontal tangent, right? Y double prime of A is greater than 0, right? So the only ways that you'd get neither, right? So neither would be if y prime of A wasn't 0, right? The reason I mention that is if y prime of A is 0 and y double prime of A is 0 too, then the test is called inconclusive. Right? It's not actually a situation. It usually means you have a saddle, but you're not entirely sure. So point being, when you're asked to do the second derivative test, it's pretty much always one of the two options. It's not usually neither, and this is what they're asking you to do. So if you know that going in, if you know that when you find the sign of y double prime, like if you find y prime of A is 0, and you find y double prime, so there's a good chance that y prime of 0 is 0. I can't swear to it yet. We'll find it in a sec, but I'm just saying it's likely. Okay, so anyway, given that information, let's go ahead and find some derivatives, right? So my y prime should be f prime of x minus g prime of x, right? So essentially what I need to do is do this derivative minus this guy's derivative. Cool. So this guy's derivative, right? So if we want to set it up, you can set it up as a couple patterns, right? So like, let's go ahead and find f prime first, right? So f prime is going to be a -1/2, right? Because that derives to just -1/2. This will end up being a 4/3 x, right? So plus 4/3 x, right? This guy's going to derive to be a -9/4 x squared, so -9/4 x squared, right? And then I can find the nth term if I want. I don't necessarily have to, right? Here's the reason I'm not going to need to find the nth term. They don't want y prime in general. They want y prime of 0, right? If I do the same thing with g prime, right? G prime, the 1 goes away. I get a -1/2 plus a 2x over 4 factorial minus a 3x squared over 6 factorial, blah, 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 blah. But I want y prime of 0, right? Y prime of 0 is going to knock out all of these terms. That's going to be f prime of 0 minus g prime of 0. Well, when I plug in x is 0, any of these terms that have x's are going to be gone. Same thing here. Any of these terms that have x's are gone. So I end up getting that this is a -1/2 minus a -1/2, which is totally 0. Again, if I know going in what the AP is going to ask me, I'm not at all surprised that y prime of 0 is 0, because this is setting me up for that second derivative test. All right, so now all we need really to answer the question about max, min, or neither is the sign of y double prime of 0. So if I go back to here, y double prime should be f double prime of x minus g double prime of x. But remember, I don't want y double prime of just anywhere. I want y double prime of 0, which really means that I'm only going to care about the terms in the f and g sequence, the double primes of those, but the f and g double primes that don't have x's. So if we come over here, I'm going to erase here for a sec so we can do a little bit more work. So my should start with your f. So f prime was, as we said, -1/2 plus 4x over 3 minus, and then honestly, I don't even care that it was this, because when I derive again, my f double prime is the -1/2 is gone. I'm going to get a 4/3 minus, I don't care that this is an 18/4 x, because everything after this has x's. So f double prime of 0 is just the 4/3, because everything after that will have an x. My g prime was the -1/2 plus 2 over 4 factorial x minus the 3x squared over, but I don't really care, right? So g double prime, the -1/2 is going to be gone. I'm going to get a 2 over 4 factorial, right? 4 factorial is a 24, right? Plus a bunch of stuff that has x's, right? I don't even care because it has x's. So g double prime of 0 is 1/12, right? So what that means is that my y double prime of 0 is 4/3 minus 1/12, right? Which is 16/12 minus 1/12, or 15/12, which you could leave as 15/12 if you want. Doesn't matter to me. You could also cancel a 3 and make it a 5/4 if you want. Okay, so the first thing I was asked to do, right? The first thing I was asked to do was find y double prime of 0, which I did, right? So in part B, I found y prime of 0, which was 0. I found y double prime of 0, which we just established was 15/12, right? But I want to point out that's greater than 0. So the next part of the question that I was asked to find is this a max or a min or neither? And say why? Well, this is the setup I was talking about. This tells you that the curve is concave up. So I'm looking at a curve that has a horizontal tangent line, but is concave up. That's a min. So by second derivative test, y prime of 0 is 0, y double prime of 0 is greater than 0, it's a min.